Hello everyone, this is Tasnia from Department of Science and Design, and today we are going to see about computer networks. And that we are going to see about unit network layer, which is RARP, which is reverse ARP. First, you just will see example. Start with example like you just bought a new laptop, but it needs an IP address. Like there's no hard drive, no configuration file, or just anything, just a tiny ROM chip. So who am I on the network? So how we will know that how will be assigning the IP address? How does the machine figure out what it is identity like that? So the problem statement: a diskless machine only its physical MAC address. It has no way to obtain its logical IP address without asking the network. So why can't it just self-assign? Like IP address are network managed by set by admin, and ROM is pre-installed by manufacturer, and IP address depends on WH which network the device joined. The same machine may use different IPs on the different network. So the main key terminology here is MAC address, IP address, diskless machine, and RARP. So how can we solve this bootstrap problem? Like there are three approaches explored over time, which is approach one is RARP, which is in 1984, and the main process simple to implement, works at the data link layer, device just broadcast its MAC. And the cons will be cannot cross the network boundaries, needs one server per subnet, returns only IP address and no extra configuration. And approach 2 is boot P, that is boot protocol, which is 1985, which across will be works across network via relay agents and returns more config information and application layer router friendly. And cons will be static configuration tables will be there and no automation. Admin must manually register each device. And approach 3 is DHCP, which is in 1993, which is fully automatic IP assignment, dynamically uses reusable IPs and works across routers. And the cons will be more complicated and requires DHCP. Actually, how IRP works, like we can see the architecture and message flow. First, we have the diskless machine, which is the RARP client. Only knows the MAC address only, and it needs the IP address. Next, RARP request will be sent across the broadcast, like who has MAC, AA, or BB, CC, like that. And the server will be responsive, like it will look up on the table and sends the IP reply. So RRP reply will be uniquest, where IP address sent back to the only to the request, not to the others. So the architecture, if we see, it contains 32 bits, and for the hardware type it occupies 16 bits, and protocol type it occupies 16 bits. Like hardware length and protocol length, it will be there will two type of hardware type, and protocol will be operation like request 3 and reply 4. First, it will send the hardware address and send where the protocol address, then target address will be noted. And target protocol address will be example 4 bytes for IP address, it will be allocated. Like in phase 1, the broadcast radius, like will be start the initiation, like newly booted client realizes it lacks an IP address. Then it will be combined, like encapsulation will be done, like client packages its MAC address into ARARP request payload. Then transmission, how then it will go for the transmission, like client sends a layer 2 Ethernet broadcast to every device on the LAN. Then filtration will be done. Most of the IP address will be sent to the destination. Next, phase 2 will be lookup and unicast reply. Like a server lookup, the server cross references the incoming MAC against its pre-configured static routing table. Once the match is found, the server identifies the corresponding IP address, creates that a hardware profile, and it will go to the targeted delivery where server generates RARP reply and sends a directed unicast frame directly to the client. Then configuration will be happen, like client receives the packet, loads the IP into the memory, and then it will be sent to the destination. So there are mirror protocol, like there's a difference between ARP and the RARP. So ARP contains RFC 826 and RARP contains RFC 903. Map knows IP to know unknown MAC, but in RARP map knows MAC to unknown IP. Client broadcast IP, ask for MAC. Client broadcast MAC, then ask for IP. 1 request, 2 reply, 3 requests, 4 reply will be done. widely used in modern network. RARP will be rarely used. How you will be evaluating the strength weakness, why it becomes obsolete of the RARP. The strength, if you see, it will be conceptually simple. No IP required to send request, works well for small and single subnet networks. When the weakness is broadcast cannot cross router, one RARP server needs per subnet returns only IP, no mask network gateway. Why it is replaced to boot protocol and DHCP like work across routers via relay agents. And DHCP is something reliable, dynamic, scalable, fully automatic. The real world use is nearly obsolete since late 90s and still found in legacy embedded system and conceptually lives in the DHCP design. The real world application, as we see, it is from 1984 to 2003. We are using now, which is DHCP v6, IPv6 support. Actually, this is a wall challenge solution. If you see and if you know the solution, let me comment. The mind map. So this is the overall summary of the RARP, the legacy dynamic of the IP discovery. So the reference you can go through the website and the protocol.